Yeah, no time to introduce myself. I'm a bit worried. There was meant to be more at the top of this slide, so hopefully the whole thing is not cropped. Anyway, comb filters. I'm here to tell you about something esoteric, but to do it quickly. So what is a comb filter? So it's a pattern of constructive and destructive phase interference between time-displaced versions of an identical audio signal forming equally spaced teeth in the frequency domain, right? Of course. But it's probably easier just to like show you what it is. Hopefully the video works. So this is a comb filter. So yeah, so actually, what is it actually? So like with sound, right? If you got a nice sine wave there, and you put another sine wave on top of it, it's the same sound, it's perfectly aligned, put on top of itself, it gets twice as big. Great. If you have sound and then you put another one next to it, but the phase is inverted or like it's offset so that the peaks line up with the troughs instead of aligning with themselves, nothing. Completely cancels out. Silence. So when you have a complex noise signal, not just a single sine wave, and then you introduce a discrepancy in time like this, you end up with a whole bunch of this freaky dance happening at different frequencies all throughout the frequency spectrum, right? So some of them are cancelling out, some of them are getting reinforced, and you end up with this like pattern of loud and soft and loud and soft and loud and soft all the way up the frequency spectrum. This sometimes happens in your video game when you don't want it to. So like if you don't have enough variance of your sounds and you've got like two boxes you want to blow up at almost exactly the same time and there's only one box blowing up noise, if they trigger a few milliseconds apart, you're going to end up with this weird sort of sound as part of that, which is funky and odd. And pitch randomization does not help. So it just creates a shifting filter. Sometimes you're trying to like play two things that are identical at the exact same time, but you're just doing it in like your regular update, function or something. A frame, if you're clocking a nice smooth 60 FPS, a frame's still like 15 milliseconds long-ish, and that is a long time in audio. And so like telling two things to happen within the one frame, it is just, you need more precision than that. And then the other thing is that like when you introduce various DSP effects or sort of routing and other stuff, it can generally, in order to be helpful and not stall the audio thread and cause other problems, add delays into the signal. But if you've got, say, your signal being routed to a reverb send or something over here, and you're playing your dry signal, the original signal, and the routed one, if the dry mix is on the routed one, there's actually going to be a delay of one like DSP mixer block of time there, which would be about 512 samples normally, which is like 1/96th of a second, whatever that is. And so that's going to give you weird comb filtering. So if you know what's going on there, you can delay the original signal or you can have a fully wet mix and so on. So how do we feel about it? No. We don't like it, right? So what's the point of comb filters? Why do we want them? Because comb filters happen in the real world, sort of. And so by studying how sounds are affected in acoustics, we can reproduce those or like do a simple quick trick with a comb filter to pretend to reproduce a complex physical reaction to psychoacoustics and confuse your brain into thinking stuff about your environment, which is very handy when you're making a video game. So there is a little demonstration moment for us all. Oh, is that howling sort of wind noise still happening back there? If you like move your hand near to your ear, I'll be quiet in a second so you can do this. You'll hear it sort of go. Right? That's cool. That's comb filtering. So what happens is you've got a sound source and you've got a U, and the sound is going to you and you hear it, and that's nice. And then you've also got like walls and stuff, and the sound will bounce off that wall. And the time it takes for the sound to reach you by both paths is different. And so there is a delay in the same sound, but it's delayed, and you get this discrepancy there, and that causes your comb filtering. And then like planes, planes, everyone knows about the Doppler effect, of course, things go past and go, but there's also like a sort of a thing that happens when planes go over. And that's because you've got this actually like shifting situation. So you've got, yeah, okay, sure, we've got this time discrepancy, we know what's going on here. As the plane moves along, this changes, this interval is changing over time. And so you get this comb filtering that is shifting, like, and that's what gives that effect. Isn't that nice? And then fireballs, just another, everyday use of this, right? No. No, not the drink. And so, wow. Actually, aren't comb filters actually kind of cool? So you can trick your brain into thinking that there is a wall there, which is maybe useful if you want to pretend that someone is in a video game and there is a wall there. There you have it. Thank you.